Gary, great to talk to you. And we've got a really cool topic to talk about this time. And I want to just jump right into it if it's okay with you. And we're going to be talking about Bluetooth. So, how does Bluetooth work?
Good to see you again, Nathan. Thank you, and a great question, right? Bluetooth technology uses short-range radio waves to establish a wireless connection between themselves, similar to a master and slave, pairing mode of operation, right? In order to be successful in the sharing of data. So these Bluetooth devices, right, are transmitters and receivers within the device, typically running over 2.5, the 2.4 gigahertz Wi-Fi frequencies. They operate within what's called the ISM bands, Nathan, which stands for Industrial, Scientific, and Medical bands. So basically, in the past, if you think about it, right, Bluetooth. These Bluetooth-enabled devices were primarily used for audio, right, audio files, listening to your favorite book or music. But with the explosive adoption of IoT and within the last few years, right, Bluetooth has moved and improved in its security and mesh capabilities, and is now being used in a more of a mission critical type role. So these data packets that are now being exchanged are now being encrypted and authenticated and so forth, and they're becoming more Bluetooth's becoming more used in as I say, a critical mode of operation. So these Bluetooth connections, radio waves, right, are now handling these mission critical command and control capabilities, which is pushing the standards to the most recent version, which is 5.3. Not too sure if you're aware of that. But 5.3, Bluetooth 5.3, which was released back in the 2021 timeframe, again offers this enhanced, improved features across performance and security compared with the previous versions, which is now allowing it to be used in a kind of more of a mass market critical deployment. So Bluetooth supports various speeds and distances depending on the version and implementation that you use. But users can typically expect download speeds of about 2 megabits per second and up to about 800 feet in distances in perfect conditions. Again, actual data throughputs will vary depending on the factors such as distance and interference, and of course the device itself's capabilities. But the effective range, or actual range, may be shorter in the real world, Nathan, depending on the obstacles and the building materials and things like that are being used in order for these Bluetooth devices, to communicate. So the bottom line here on Bluetooth, Nathan, is that this Bluetooth technology is versatile across many industries and in many ways, and it's used in a wide range of applications, from wireless audio streaming to hands-free communications to smart home automation to fitness tracking applications and so forth, and of course now significant IoT connectivity. So it's an exciting technology, and it's not going away anytime soon as the Bluetooth adoption becomes more prolific.
Good stuff. So you mentioned some different versions and different things that have happened as Bluetooth has evolved and all that. So I have a question with what are the differences between what I know as Bluetooth Classic and Bluetooth Low Energy?
Okay, yeah, a great question, because there's a number of iterations, and of course, Bluetooth Classic is typically optimized for high-speed data transfer and continuous connections, making it suitable for applications like audio streaming and file transfer. In contrast, Bluetooth Low Energy (BLE) is designed for low power intermittent communications, making it ideal for IoT devices like wearables and applications requiring long battery life. So that's really the main difference there. BLE, Bluetooth Low Energy, consumes significantly lower or less power than Bluetooth Classic, allowing devices to operate over extended periods of times on small batteries. That's the key difference, Nathan.
Great. Thanks for explaining that. And with Bluetooth, what is the maximum range we're talking about for these devices?
Yeah, again, good question. So as kind of previously mentioned, right, the maximum range of Bluetooth technology varies depending on the version and implementation, BLE versus Classic. But Bluetooth, 5.3, the Classic, offers this extended range compared to previous versions with a maximum range of about 800 feet in ideal conditions. And with the emergence of Bluetooth Low Energy, BLE, also known as Bluetooth Smart, which is really optimized for low consumption and shorter range communications. So BLE typically has a shorter connectivity range of about 100 meters, 330 feet in ideal conditions. And this technology has been used in various IoT applications such as wearable technologies, as well as smartphone applications, due to the energy efficiency and reliability of that connectivity capability. So BLE short range, Bluetooth Classic greater range and throughput.
Makes a lot of sense with the differentiation there.
Yep,
So
that's the main difference.
as we're talking through these and everything, the question that we always are concerned with here is how secure are these Bluetooth devices?
Okay, good question. Thank you, Nathan. So Bluetooth technology involves various or includes various built-in security features to protect against unauthorized access, interception, eavesdropping, and tampering, and so forth. We've talked about those a number of times on different podcasts, right? But these new features in Bluetooth 5.3 include things like encryption, authentication, and authorization mechanisms to ensure secure communications of these devices. However, that being said, there are vulnerabilities within Bluetooth, and of course attacks that are emerging, which are still associated and relevant in Bluetooth, such as Bluetooth jacking, Bluetooth spoofing, and Bluetooth sniffing, if you're familiar with those types of terminologies. So in the case of mitigating Bluetooth risks and threats, right, obviously it's crucial to be able to secure these devices within the wireless communications. And of course, it requires continuous, regular updates of these encryptions and protocols and so forth in order to stay safe. But if you look at things like let's pick blue jacking, for instance, like blue jacking, right? That involves sending unsolicited messages to or files to the Bluetooth enabled device within proximity, of course, and is used typically for spamming or social engineering types of attacks. Bluetooth spoofing is where attackers can impersonate legitimate Bluetooth devices to gain unauthorized access to a user's device or network. And of course, this can lead to data theft, malware installations or infestations, right, or other malicious types of activities. And then, of course, there's other types of attacks associated with Bluetooth, such as denial of service, right? This is where attackers can launch a denial of service attack to disrupt the operation and Bluetooth connectivity of devices and networks. So that's very problematic. You also have attacks like Blueborn, which is widely known within the industry, which is a set of vulnerabilities affecting various Bluetooth-enabled devices, allowing attackers to execute arbitrary code, perform man-in-the-middle types of attacks, Nathan. So that's very problematic, right? Getting in the middle of the data stream. So again, right, Bluetooth represents opportunity as well as risk. Therefore, I would say continuous monitoring of the environment for any deviation of policy or unacceptable exposure states is crucial within the deployment of IoT, particularly in Bluetooth, to prevent a data breach. So there's certain risks and threats that customers need to be aware of.
Sure. Makes complete sense and stuff that we've kind of hit on in the past, but a different iteration or version of it when it comes to Bluetooth.
Exactly.
So with that, you mentioned some of the opportunities that are available with Bluetooth. So what are some of the, emerging Bluetooth applications, opportunities, and trends that we're seeing?
Yeah, thank you for the question, Nathan. I think as Bluetooth continues to evolve across various industries, some of the emerging trends that are improving the use or the adoption of Bluetooth include, this mesh capability that's now built into it. This is allowing for larger scale IoT deployments due to better multi-device connectivity. So in the past, it was really just one-on-one, your headset to your phone. Well, in Bluetooth 5.3, there's now a mesh capability that allows for multi-device connectivity, which is going on. So that's an emerging trend that's making Bluetooth more acceptable and readily available for adoption. We're also seeing Bluetooth, obviously, audio enhancements as well for not only for improved sound quality, but with the adoption of voice biometrics for now, authenticating users onto the network, having reliable Bluetooth voice enhancements, allowing to really understand this is Gary, authenticating to the network versus Nathan authenticating to the network is key. So we're seeing that trend within Bluetooth, helping to improve the audio enhancements there. We're also seeing Bluetooth location services driving adoption for indoor navigation and asset tracking for next generation Bluetooth, being adopted as well. So, so that's another area that's driving business, right? The ability to, navigate and map where things are within the building. And I would say also, next generation Bluetooth is being adopted by the automotive industry for vehicle-to-vehicle communications for emergency services, as well as for infotainment type systems that are now being deployed that are Bluetooth enabled. So the adoption of Bluetooth is very prolific across different industries, but that's some of the key industries and technology capabilities that are allowing for the adoption of Bluetooth to be embraced, if that makes sense.
Absolutely. Oh, yeah, absolutely. Lots of opportunity out there in those industries and a lot of others, I'm sure, too. So we've talked about the security aspects of Bluetooth in what the risks and threats are, but what do you have from a security perspective? What are the recommendations you give to your customers for security recommendations in regards to Bluetooth, Gary?
I would suggest that in order to implement a best practice and in order to mitigate the Bluetooth risks and threats that I just talked about a few minutes ago, right? Again, multiple strategies need to be adopted. And I would say starting with, security strategy number one, right? You need strong authentication and authorization needs to be implemented in order to have a robust, security mechanism in place, such as multi-factor with strong passwords, unique passwords to prevent unauthorized access to the Bluetooth device or network itself. Strategy number one. I would say strategy number two is the need to implement secure communication protocols. I spoke about this a number of times. Typically within the Wi-Fi frequency in the past, it's been unencrypted, and therefore it's a shared medium, which is really no longer acceptable, right? Being able to eavesdrop and listen into people's communications is a bad idea. So strategy number two is to implement the secure communication protocols such as SSL and TLS to secure that communication channel between Bluetooth devices and the back-end systems. I would say strategy number three is network segmentation and isolation, right? You need to segment your Bluetooth or IoT devices and applications onto a separate network zone based on their criticality and sensitivity, and enforce strict network segmentation policies to isolate them from your normal working environment, because there are a lot of risks and threats today on the market associated with Bluetooth and associated with IoT, but also they're continuing to evolve, and a lot of zero-day attacks are coming through via wireless and via these IoT types of communications. So I would say strategy number three is to have solid network segmentation in place as well. And then I think, finally, just because of the time constraints here, I'd say strategy number 4 would be that you need to implement a continuous wireless threat monitoring platform that not only understands the risk of threats associated with Bluetooth, but all things wireless within your airspace. That is critical, right? There's new risks and threats stemming from layer 0, layer 1, as well as layer 2, where Bluetooth lives, and being able to identify risks and threats quickly is really important. So customers need to be aware of these new risks and threats, particularly layer 0, layer 1, really before an IP is assigned. But in the case of Bluetooth, we'll say an IP is assigned, and therefore, the wireless threat detection is critical. So it's a combination of layer 0, 1, and 2 threat detection is key here. So I would suggest that in this particular case, right, the deployment of LOCK's AirShield wireless airspace defense platform would not only provide an understanding of the wireless network infrastructure being used, but also the wireless client behaviors that are in use, regardless, of the application. Of course, in this particular case, we're talking Bluetooth specifically. So having an AirShield, and here's an AirShield here, looks like an access point, the same size of an access point, being able to be deployed within your environment that's shazamming the airspace of layer 0, 1, and 2 threats, and looking at the infrastructure, looking at the client behavior, and identifying risks and threats before loss or incident occur is really critical. So I would say that's strategy number 4 there. And again, having this AirShield, not only looking at the network traffic, but also providing validation of the transactional data going between the device and the network is critical. And this will detect malware, this will detect zero-day attacks, because we're looking at the data and looking at exposure states or any attacks in flight prior to loss or prior to any incident occurring, Nathan.
Good stuff. Well, those are great suggestions, and I really appreciate it, Gary. Thanks so much for your time.
Yeah, I just think 24/7 monitoring is crucial. It's crucial just in Bluetooth and IoT environments in general. And with 80% of IoT devices being wirelessly connected today, why wouldn't you want a monitoring system in place to be able to detect, assess, and prevent risk from Bluetooth or any wireless for that matter? But anyway, appreciate the questions. Thank you very much, Nathan.
Absolutely. Have a good one, Gary.
Thank you.